عرض سلام و خیر مقدم مجدد دارم خدمت مدعوین عزیز. یه چند مورد فقط لازم دونستم تذکر بدم واسه سوالاتون. هم توی گفتم اول جلسه اگه لطف کنید اسلاید یا همون سوالی که میخواید بپرسید و بنویسید. ما آخر سر نیم ساعت 40 دقیقه وقت داریم که سوالا رو مطرح کنیم. خود دکتر و جناب دونان اینجا هستن که جواب بدن که یکم در بحث تایم صرفه جویی بشه. کاتالوگ خدمتتون هست رو هر دستگاهی که میرن. اگه لطف کنید نگاهی بندازید بهش، خیلی بهتر متوجه بحث میشین. از این لحاظ خیلی بهتره. و اینکه طرز استفاده تمام این دستگاه تو یوتیوب اگه سرچ کنید هست. خود سایت پروسک هم داخلشون برید، داخل سایت برید، واسه خیلی از دستگاه یه سری فایل‌های تصویری وبینار داره، میتونید از اون هم استفاده کنید واسه دیدن طرز استفاده این دستگاه. واسه این بخش جناب پاتریک دستگاه پاندیز رو میخوان توضیح بدن و بعدش دیگه طبق همون تایم تیبل جلو میریم.
Let's start with ultrasonic pulse echo technology. It's a concrete imaging technology. Maybe you have also heard about GPR, ground penetration technology, ground penetration radar system. Pulse echo is also one concrete imaging technology. When we talk about imaging technology, we talk about tomography. It's like you do a scan and then it's cut it down like a section. When you do drawings, you do a section that you see the picture. Here is the volume, the cube. You do a scan like this line, and then you get a section out of it. You see inside. That's the image. When we were talking first of the amplitudes, like an A scan, with the B scan, we talk about software-related transfer from the A scan into a picture. This I will show you. When we talk about the pulse echo, we talk about this probe, spring-loaded, 9 transducer, 9 receiver. You can see here. For better understanding, that you cannot go with the pundit pulse echo this way. You won't get a picture. Why? Because like you see here, red and blue, transducer, receiver, it is all the time linked. This is the calibration plate, and then you have this together. So make sure if you use this pulse echo machine instrument, you go this way or this way, not up and down, because then it doesn't make sense. You have to have an overlapping, otherwise you don't get these images what we have seen. What is happening with ultrasonic? You have concrete and the second material. Then you will get a different result. The wave is running, second material, the wave is changing. When we talk about this wave, we talk about amplitude. So this is the zero line. Here I have plus, here I have minus, or opposite. Most important to know is on pulse echo, when we talk about ultrasonic, the most important thing is to know that air is like a mirror. You have 99% reflection. On steel, 66, what means 2/3 go back as an echo, 1/3 is going through steel. When we talk about GPR, 100% is going back. On granite, like rocks, stone, is more or less like concrete. 50% is going through, 50% is going back. Let's have a look how it looks like. On air, you get a big reflection. On steel, you get a smaller reflection. 1/3 is going through. And on granite, half is going through, half is coming back. So when we talk about the homogeneity, it's also good to know the speed. Air has a slow speed. Concrete has 4,000. We have seen first 3,000 to 5,000. And steel is usually above 5,000 to 6,000. And it depends on which material it is. But when we talk about rebar steel, usually somewhere 6,000. So this is good to remember all the time when you do a lot of projects with ultrasonic, because this will give you also the information, am I right or am I not correct? So when we talk about A-scan, you can see here the wave, zero line, let's say plus, minus, and then you have this waveform, like an amplitude, like the sinus curve. Here we talk about the technology. When it comes to these pictures, we talk just of B-scan. It's a 2D picture, not a 3D. This is only a picture of the A-scan. So you get this. This you have to understand. Then you will work easily with this. My mistake when I started, I tried to understand this. No, it doesn't work. Then you don't know the methodology. So this was my mistake at the beginning. That's why try this first, then go to the pictures. Then you will have a nicer work. What is happening? Here is the zero line. So close to the zero line, you have the blue. One English customer said to me, oh, if I see the boring blue, the homogeneity is good. Yes. There's no void, no crack, no different material. The bigger the amplitude is getting, the brighter is the color. Like here, a light green, blue. Then here is the yellow missing, then orange, and then red. So you can see here. I take this one. If you go here, we talk about the blue. With this one, it's not correct because of the presentation. We talk about light colors. And then red, all instruments with us is green is good, orange is attention, red is stop, like the traffic light. So when I see red here, I know I have a big amplitude. I'm talking about air. I would say it's air. It's not 100% sure, but my first suggestion is it is air. Bless you. So when we see it on a concrete block, we have a D, we want to check the distance. There's one more thing to know, that you don't get confused with these pictures. So you have this. We know energy is never ending. It's bouncing like a ping pong. It's dropping until the end, and then it's rolling. The same is happening with the waves. You send one wave from the transducer to the receiver, you get one signal. But it's bouncing back and forth. So you get another signal and another one. A strong one, this is my dimension. This is 2 times D. And there's a smaller one, 3 times D. So at the beginning, this can be confusing. But the moment I understand this, it's quite relaxing. You don't think about this. Why? You check. Let's say a sample is 20 centimeter, is D, 200 millimeter. If my second result, I can do it with the cursor here on the screen. If I have 40, fine. If I have 60, fine. If there's something like 50, I don't care. It's not related to this. If I did the calibration correct with the on-site, I can measure, okay, 20 centimeter, I do my tests. When we talk about these results, it's just the delta T. As we have seen first with the transducer, one impulse is sent to the concrete, and then there's a receiver, and then the delta T will be calculated. And with this delta T, you get these results. Better say these results, what will form these pictures. Sorry, there's the formula for this, that you have the velocity times delta T divided by 2. So coming to the B scan and the A scan, as I have said, when I use it here, I don't walk this way like you see. I want to do a section like cutting the bread. I want to have this section, I cut it through, and then I get this picture. So I go this way to get the image from this concrete block inside. I don't walk this way. How does it look like? Here you can see, step by step, you get signal, and with this the software is doing the picture. Again, signal, picture, signal, picture. So try to understand first the A-scan. It will make your testing time easier. When we talk about the correct measurement procedure, scan with pulse echo technology, useful information is obtained by performing A-scan. Isolated measurements are only useful for obtaining a sample thickness estimate. So this is more or less to use. And the good thing is to know, especially when you do big projects with the measurement grid, we don't have a roll, you have to go step by step. So here you can read 10 to 20 centimeter. This is approximately 15 centimeter. So if you step 20 centimeter, you will have a gap. It's okay. I prefer from the technical side that I just use more or less 80% so that I overlap for 2.5 centimeter. If I have to do this wall, I just do big steps. Okay, there's some inhomogeneity. I do a mark, I go on, and then I go back and I do it a second time, and then I do steps, maybe 1 centimeter and 1 centimeter, so that I get a detailed information about this extra mark. Calibration, as I have said, please do it on site. On site in the concrete you will have rebars. You will see this is exactly the concrete. When I'm home, maybe I have in the office, in the laboratory, maybe I have perfect concrete, maybe with a bit of not so many rocks inside. So I get the different calibration. Do it on site. Those 5 minutes to 10 minutes will save a lot of wasting time if you did it wrong. This is what we have seen before with the transducers on the velocity. The D, L divided D should be bigger than 2. Why? You will see it here. Not here with the next one. The time here should be shorter than this one. Because if you do it on small cubes, what will happen? If you do it on such a small cube, you will get one result perfect. But you will get this extra noise. Then you cannot read your results. So make sure the length is wider than the depth. Otherwise, you have these extra results and you cannot read exactly what is the correct result. So this information is giving us the result that this way we don't measure because it doesn't make sense. We cannot read the results. Even on E-scan, even experts won't read the correct results. So we do the measurement over here. When we come to B-scan, those concrete blocks are from our master training back in Switzerland. You have this block here, 400 millimeter, 500, 400. The scan, you can see here the red line. It's just this direction, but the scan was made here. And then you have 400 millimeter here, 500 millimeter here, and 400 millimeter here. And now you can see something very special on here, but what is very informative for the future when you do tests on that. The moment if it is not flat, like we know, like something, I don't know if you can see, something if it is flat, we don't talk about angles, it will bounce back like this, the ping pong. The moment it is like this, it will bounce back in a different angle. So here you can see from bouncing back the waves are coming together, so you will have here an echo, and the biggest echo you will have here, because here is the corner, because it's not rectangle. So this you will see quite often if you do tests, that first check how are the angles, and then you will also recognize, okay, this echo correct, this echo doesn't make sense, it's just because of delamination and something is going through. You will see. So when we talk about not testing dimension, distance, but we talk about checking voids inside. We have seen first, air is a big reflector, like our mirror in back home in the morning, and the steel is not as big. What happens here? You will get these signals. Then you can see the green one, and this is a typical shape. Can everybody see this shape here? You have this, we will see another one, and here you have the blue. This is the first, this is this one, so it is too short for the back wall. Then this is a longer distance as usual, because it has to go around, so you get it a bit wider. And then you have the next one, what is coming because of going back. So you get this, it's called I, back wall, and this is the void. Let's have a look on this. This is a characteristic echo for these voids, and this is also used because we know this is a characteristic echo. This is used with the software system SAFT. I already explained it to my colleagues over here. SAFT means in English choose. And SAFT is for, you will see, it's synthetic aperture focusing technique, but in my German language, SAFT is choose. So if I drink a juice, I drink a SAFT in German. But SAFT, synthetic aperture focusing technique, is helping us to get these voids done. How is it happening? Have a look on the steps. You get this. You get again this picture, and then the software will do an overlaying layer, and then this will be split in small blocks, and then it will be calculated how big the hole should be that I get this result. And this is done more or less with the velocity of the ultrasonic. So you have this hole. And it's quite useful to find these holes when you have, this is again a master block of our master design, master training. You can have a look, 125 millimeter, 60 millimeter in diameter, 50 millimeter in diameter with 145, 190 and 40. When we talk about 50 millimeter and 40 is like a ping pong ball, this is the limit. To the maximum, there is not a limit. But to the minimum, especially when it is getting deeper, 40 millimeter will be the maximum. The minimum, the maximum of the minimum. So we have learned air is a big reflection. Steel is not as big. So what is good to know with this? If I have a big reflection here and I see on the back wall a shadow, it should be air. Because we know steel will transform some way through, then the shadow wouldn't be that big. And granite the same. With the second hole, it's smaller because the diameter is smaller and the distance is longer. And as we have seen, the wave go around the air because it's not going through. This is, please remember this. Here we have a longer distance and only 4 centimeter, so the back wall is better seen and the shadow is not as big. So when we see these pictures, you can see if you use the SAFT from the software, you can see. If you switch it off, you won't see a lot. So in this way, the software is interesting for us. We have to understand the signals, but then again, for the pictures, the software is helping us. This is what I said at the beginning. First learn the A scan, then we will have fun with the B scans. Then there's another software option, is time chain compensation. If we have a look here is without. The back wall is not so nice to see as if we switch it on, because then it's compensating. So I get my echo signals on the correct place. Let's have a look. Here straight, echo, echo, up to here, and here also. So on these AirPods, air voids, there's shadow behind. That's good to know, because this is very useful for interpreting. And one thing I can show at the end is that you can use the cursor. We just have it at the break. I can go there, I can measure how deep it is, and on this side I see the A scan. And then I can say, okay, that's correct. Here you see the cursor. I can bring it wherever I want, and then I see the A scan. And yes, here the wave is starting, so I have the correct signal and the correct distance, and then we talk about 12 to 13 millimeter. This you can do on the instrument and with the PL-Link software on the computer. This is how it looks like. This is again the concrete block, and then you see it's more or less overlapped. You can see the back wall. You can see the distances. And yesterday I got asked how accurate you can do, how accurate you can say how big is the void. Let's say if it is close to the surface, starting from 10 to 20 and the hole is big, plus minus 5 millimeter. When we come to the limitation of 40 and the longer distance, I would say plus minus 15 millimeter, 10 to 50 millimeter, just to give you an assumption how you can calculate. When we come to delamination, for delamination you will see on the pictures, we don't use soft, because then you cannot read it that nice. Why? Soft is compensating results. So you get this extra points, like a hole, but it's not a hole. So it is better to use, here you can see with soft. Here it's quite okay. Sometimes it's more difficult to understand, but if you switch it off and use no envelope, you will see the point starting, but then you will see the correct line here. Why don't you see it here? We have said before, when you have a steep angle, the bouncing is not giving you the echo here. Usually you get the echo here, but then it's not correct. So you get the bouncing here, and then on the top end here is getting flatter, so you get a nicer echo over here. This is more or less my presentation to the Pundit lab. Pundit Pulse Echo. Do I have 2 minutes? I want to show you what I have said before. Like here, what I have said, you can use the cursor and then you can see the signals. You can make it bigger. You can check, okay, 25 millimeter. And then I will show you here on this file the setting of the steps distance between the measurements is 10 millimeter. So every time you can read 26 on the top here, and if I next step is 25 is exactly 1 centimeter, and then I can check again. And one important thing, because of calibration, I just key in a strange number like 5,000. We had 25. Now we have 52. You can see the calibration is done on the construction site, then you will have correct measurements. If you do it first and then you just let it be, you can have maybe wrong dimensions. That's from my side.
در حدود 6-7 دقیقه 10 دقیقه وقت هست. اگه سوالی دارید الان بپرسید، چون دکترم خودشون هستن جواب بدن. خب
How long is the effective depth of the scan that we made?
The
Effective depth in the concrete that
1 meter. With pulse echo you can do 1 meter. Here we talk about up to 16-20 meter. This is more or less what you use on the bridge, but if you have a lot of post-tension cable inside and this, it could be 15 meter. So this has to be checked. But when you have very good homogeneity inside, you can do up to 20.
توضیح خدمتتون بدم. این قسمت اکو رو من خیلی وارد نیستم، در واقع خیلی کار نکردم نمیدونم، ولی در قسمت اولتراسونیک، حالا این سوال شما به اولتراسونیک هم برمیگرده. دستگاهایی که ما برای اولتراسونیک معمولا داریم 54 کیلوهرتزه، داد می‌کنیم تو بتون. دستگاه‌های اولتراسونیک با فرکانس‌های مختلفی ساخته میشه یا حالا پروبای مختلفی برای این کار وجود داره. هرچی شما ضخامت رو بیشتر کنید، قبلا هم ایشون توضیح داد، از بعد فرکانس کمتری استفاده کنید. مثلا شما اگه بخواید یه جایی که 2 متر مثلا ضخامت داره در واقع اولتراسونیک کار کنید، تو اون عمق 2 متر شما باید مثلا برید فرکانس مثلا 20 کیلوهرتز رو در نظر بگیرید. اما اگه مثلا خواستید بیایید مثلا یه قطعات مثلا با ضخامت مثلا 10 سانت 8 سانت چیزی کار بکنید، ممکن لازم باشه برید فرکانس 100 کیلوهرتز رو مثلا در نظر بگیرید. البته دستگاه معمولا تا حدود 150 اینطورا خورده‌ای کیلوهرتز ساخته میشن که برای خیلی قطعات نازکتر هستن، مثلا واسه جوش و اینا خیلی فرکانس چی میشه؟ زیاد میشه، چون میخواید تو ضخامت کم در واقع کار بکنی، فرکانس بیشتری رو استفاده میکنیم. بنابراین این که ما معمولا یه دستگاه با یک فرکانس مشخص با یه پروبای برای اون فرکانس داریم، این کفایت نمیکنه که همه قطعات بتونی رو با اون مورد بررسی قرار بده. این نکته حالا شما باشد مال اکو رو پرسید، ولی من یادم افتاد که مال التراسونیک رو هم یه همچین توضیحی لازمه براش بدیم.
اگه دوستان سوال دیگه در ارتباط با این بخش پاندیس و پاسکو دارن میتونن بپرسن، از جان پاتریک بپرسن یا خودشون مستقیما میتونن سوالشون رو مطرح کنن.
for vertical scans you can use with rotating the scanner you can do it, okay?
Yes.
No problem. For vertical.
Sorry, this was the wrong explanation.
اینطوری برید، بعد بیایید کنارش اینجوری بگیرید، لازم نیست اینطوری برید. باشه اینطوری میری جلو، یعنی یه نوارای اینطوری درست میکنید، اینطوری میری جلو.
یه چیزی میخوان نشون بدم.
No, it's okay. I think everybody can hear me. It's easier. Then I feel more relaxed.
They want to record your voice.
Oh, okay. Okay. Sorry, first the answer. I made a mistake with just saying this way. You can go vertical and horizontal. What I wanted to say is that every time you remind transducer, receiver. So you do the scan this way or this way.
Do you use an agent like gel or any other lubricant for plastic or instrument?
One more time, please.
Multiple sensors. Do you use a gel?
No. Good question. Here, because of spring-loaded. Okay? Yeah, now it's okay. Because of spring-loaded, no, you don't need a gel. And you have seen first, let me go through, let me go back first for this, please. There are two possibilities that you don't use couple-based. In Germany, I have a customer who is using these ones because he's not allowed because of very expensive marble on sculptures testing if there's for sure no crack because they do the sculptures for art, so they want to make sure there's no crack. They have to use this because every other one has to be used with couple-based. Sometimes you have a very rough surface. Couple-based is more or less, I brought it with me, it's just liquid. So when you have on the streets a rough surface, it's also not that nice. What you can use, I'm not too sure what it is in English. You know, when the kids play with this plastiline, I know, it's green, yellow, you can use, it's really good to use. You push it on the rough surface and then you use this, and if it is not enough you can use this or just a bit of honey, just some liquid. No, you know, I will check at the break. It's plastiline, you can form some animals and this.
P-U-T-Y.
Is it the word in English? Okay. So this one and the pulsejo without couple-based, the rest is with couple-based. And share waves, it's a brown couple-based, not the same. It's very sticky, but they're very useful to get the E-modulus. It's sticky and it's better to use. You have better contacts. Okay?